Hello everybody! I'm glad you are here attending to my talk where we talk about the evolution of delivering software at Klarna. But first, I want to introduce you to our fictional character, Sven. Sven, as you can see by the Node.js shirt, is a TypeScript, JavaScript engineer. By his name, you can guess that he's a Swede, but he works at Klarna, a Swedish company that has more than 100 nationalities. Well, Sven is in charge of creating a new service, and as any software project, it might involve class diagrams, sequence diagrams, etc. However, man does not leave the bread alone. Here at Klarna, engineers are responsible for the whole life cycle of the service, meaning that they code it, ship it, and operate it for the entire lifespan thereof. Consequently, besides coding, they are submerged into a pool of several technologies that will help them during these tasks. That is exactly where Sven gets stuck. As you can see, many technologies are serving different or even similar purposes, from compute resources to observing the service. Thus, choosing where to start is not an easy task in itself. Furthermore, it's not only about using it. Once an engineer uses it, they will also need to adapt these tools to our necessities. Then, all of a sudden, a person dressed in a Kubernetes shirt springs out of nowhere. This person says, wait, what if I told you that you can leave most of these tasks to me and focus on delivering new features to our customers while still keeping the ability to operate it outright? Wouldn't that be amazing? Yeah, that person over there is me. Yeah, that's right. I'm Guilherme. I'm a senior site reliability engineer at Klarna. Containers are my passion, and deploying them is what I do for fun. So I'm here to show you how Klarna has been saving priceless engineering cycles by investing in delivery automation. To start with, we'll talk about Klarna, how customer-obsessed we are, and how our engineers work. Then, the challenges that our developers face on a daily basis. At last, you're going to understand how we stepped in to help them out with an introduction to C2C, our internal delivery platform. And at the end, you have a short summary. Now, buckle yourself up and let's get started. Let's talk numbers. With over 90 million global active users and 2 million transactions a day, Klarna is meeting the changing demands of consumers who want to shop, pay, and bank on one intuitive platform and with one trusted brand. Klarna is one of the most highly valued fintechs globally, with a valuation of 45.6 billion. Klarna was founded in 2005, has over 4,000 employees, and is active in 17 markets. Do you want to shop? Klarna will make your shopping experience smooth. Do you want to pay? Klarna will allow you to choose how you pay for the goods. Do you want to track your finances on a single platform? Klarna is a bank. Actually, this is a very important point. We are a bank, and as any other bank, we need to adhere with the regulatory requirements imposed by authorities. Customer obsession is one of our principles, and we act accordingly. An example is my team's mission. We facilitate the software engineer's journey into providing the best experience for our customers. It is also important to mention that we stick to all our principles from the beginning to the end, from signing up for Klarna to making your first purchase to storing your data following our service terms and conditions. Our principles back every single process in Klarna. However, as you can imagine, this is not a simple task. We have constantly been growing, and we need to make sure that we keep growing without sacrificing the pillars that enable us to deliver the best product at a high pace. When it comes to serving customers, one of our primary concerns is maintaining our high security standards. That is a must-to-have since our customers trust us with their data. Today we have approximately 2,000 services and the mission of making sure that every single service in Klarna follows our guidelines. We have approximately 350 engineering teams at Klarna. Therefore, it's of utmost importance that all the teams and ultimately their services comply with the regulations imposed by the authorities. It includes, but is not limited to, making sure that audit logs are being sent to the proper place, we regularly update our infrastructure, and we follow review processes. But nobody likes to be blocked by a bureaucratic process, right? This is why autonomy is also a challenge. On the one hand, the team still require the freedom to develop their solutions and deliver improvements at their own pace. On the other hand, we need to ensure that all the requirements mentioned in the previous slides are met. Now, let's visualize how Sven would get his task done. Suppose that the service in this context is a simple stateless service that, given specific parameters, answers with Klarna logo that fits the frame. The service is ready to be shipped. Test coverage is high. Documentation is shining bright. And his service is performant enough. As you probably have already guessed, it runs in a container. So what happens now? There is an extensive gap between being ready to be shipped and be shipped. To start off, Klarna is running on the cloud, so Sven needs a cloud environment to run his service. What does that mean? Well, it means that he needs to find internal documentation on creating a cloud environment and get access to it. Sounds like fun, right? But of course, he manages to do that. So with the cloud environment in place, now he needs compute resources to run that container. As for simplification, we will proceed with the simplest path, the well-known virtual machine. Remember that it's not only about creating a virtual machine. Sven has to follow our guidelines for building infrastructure, which includes, but is not limited to, configuration as code, running with only up-to-date and approved machine images, and secure the network surrounding it. We're not covering this because otherwise we would need to draw too many components in this picture, making it unreadable. Okay, but with the virtual machine in place, everything is available, Sven can run his container on top of it. Of course, this process needs to be automated, and Sven has probably spent a few days automating this process. What happens now? As the service is stateless and we need to answer with a picture, Sven must create a database. Creating a database is simple in its essence, but it takes time. After creating this database and adapting his automation to including a database, fixing all the networking issues that had probably popped up during this process, he now can use his service at last. Little by little we get there. But it's not enough though. To make sure his service is available on the internet, he researched online for how to expose my service securely. So as a result, he found that a load balancer would help me out because of the security features he could implement. Actually, that's right. Implementing a load balancer generally brings more benefits to the setup than just load balancing. So he did it. We are almost done, right? But with experience, we learn never to underestimate the last mile. Sven then realizes that he needs to ask the network team to configure a DNS record for his application. So he tests it and makes sure nobody else in the company claims his DNS record. Great, now his service is available for the customers to use it. Yay! What a journey, right? With the service adoption growing, there is a need for scaling the service so it can serve the demand. Good news for him. He implemented the load balancer and he can add more power to it with ease. However, this is just the beginning. Klarna is a massive ecosystem, and soon Sven will need to integrate his service with several other services, leading him to ask questions like, how can I connect my service to other services? Is latency between regions a problem? Moreover, as this is running within Klarna's ecosystem, SOC gets into the scene asking questions like, is that load balancer only using secure encryption ciphers? Is the setup protected against DDoS attacks, SQL injections, etc.? Compliance is also banging on the door. Are the audit logs being collected? Is there a process to ensure that the virtual machine's operating system is up to date? Are you following all the guidelines? I don't know whether or not this is a good news, but Sven is not in loneliness. Many other colleagues have to go through the same process, and the cycle is repeated over and over again. This leads the company to spend priceless engineering cycles on repetitive tasks, as opposed to letting software engineers focus on develop the product. Now, without further ado, it's with great pleasure and a little bit of proud that I introduce you to C2C. Yeah, C2C stands for Code to Customer. Yeah, Code to Customer. You code it, we make it available to the customers. And its development started in 2018. C2C is an SRE developed product that empowers developers in Klarna to create and operate container-based applications with minimal effort. Developers will develop, and C2C will make their lives easier. Meaning that every team still needs to be compliant and follow all the processes. Every team still needs to follow all the security guidelines, and the teams will still need to operate their services. Although now, C2C handles the hassle of providing infrastructure, delivers all the security best practices with no effort for the engineers, and makes sure that all the processes are compliant in an automated way. Isn't it remarkable? But it doesn't stop there. In addition to that, C2C does not interfere with the development lifecycle of the services or teams. Therefore, your team will keep working the same way, with the same tools, and when the deployment time comes, you delegate it to C2C, and we do the rest based on your configuration and your needs. Let's start from the bottom up. Containers require resources to run, so we instantiate containers on so-called runtime platforms. Consequently, after C2C has checked the image and has replicated it to the target regions, it will end up running on a service platform. The runtime platforms themselves are a world apart. I can even do a full talk on how the runtime platforms work, but it's not why I'm here today. We provision and we operate these platforms. The developer will never need to bother about it. Furthermore, they might be a Kubernetes cluster. Well, come on, you saw the shirt I was wearing in the previous slide, didn't you? Or an ECS cluster. We deploy them into Azure or AWS. By the way, this is a very complicated topic, so why would you or any developer handle the complexity of doing it? A runtime platform might be an ECS cluster running in EU West 1 or a Kubernetes cluster running in East US. The developers tells us what they need, or in other words, their intent, and we do the heavy lifting of translating their intent into resources. And that is not the end. We are present in 17 markets, and running services across the globe is another complex task. Hence, C2C handles most of the complexity of doing it. Then developers can use their priceless time to solve problems at the application layer. I would like to open a parenthesis here. C2C is not only the automation of creating resources on a runtime platform. C2C applies the technology and adapts it to our needs, while still using all the best practices we have been developed since the product started. Furthermore, the platform users will not even notice that we have been continuously working on improvements in the platform. Right now, you see, this is an abstraction and a simplified view of the product. Talking about business logic, every single service in Klarna has to follow certain processes and contain specific metadata. C2C automatically makes sure that this data is present and available at a proper place. It's more than certain to say that infrastructure is exposed to compliance requirements, which we handle with automation at a center point instead of having developers do it at many points. Once again, platform users will never ever notice that somebody is doing such a thing. As we are a bank, we have security concerns, and of course, we deliver the most secure environment that we can provide. So the platform users won't need to reinvent the wheel. And when it comes to add-ons, our platforms also provides developers with services that other SRE teams develop. For example, an experimentation platform and logging capabilities. We also develop an authorization mechanism, so only the team owner can act upon a given service. This design allows us to make any maintenance on the beneath platform. For example, to create, delete, and update the runtime platforms, migrate from one platform to another, adopt another cloud provider, or stop using a cloud provider. All these tasks become undisruptive for the developers, and some will not even notice that we do it. With that said, let's come back to Sven for just a second. How would that work? In the same way, everything starts with the service being ready to be shipped. At this point, Sven creates a deployment in C2C. C2C then checks if the artifact complies with the compliance criteria we have established at Klarna. This now is automated, and developers don't need to mark checkboxes in a notebook. Not anymore. If the check passes, the service will be replicated to all the target regions and C2C deploys it. No manual tasks and no repetitive tasks. Not anymore. The delivery is automated. As for delivery, we didn't even give options for the developers to decide how they want to release their new code. Chief among them is canary deployment. Sven is not the only one enjoying the perk of using C2C. Everybody is using C2C. Consequently, once the company has an SRE team that focused on building such a platform, all the product teams can focus on the product. It reduces the pressure on the product teams and, in the end, reduces the amount of time the company as a whole is spent on provisioning infrastructure without affecting the team's autonomy. But wait up there. It's not all moonlight and roses. By this point, you might be wondering, how can Sven and his colleagues operate their services now that they don't even touch the infrastructure? Well, that's a crucial point for us as the delivery platform providers. What I have to say is that observability is critical for the success of such a platform. That's why we have a whole session for it. If we get a thin slice of the infrastructure running the services, we would get something like this. A runtime platform, which is ultimately running with a virtual machine. In this case, the virtual machine is slightly different from the one that a developer would provision themselves. And guess what? Yeah, in this example, we are going to use a Kubernetes cluster and Linux-based virtual machines. Yeah, I knew that. Then, on top of that, we find the container engine. In this example, Docker. And, of course, the container, which is ultimately a process. But wait a bit. There is a subtle separation between what the developer manages and what is managed by the SRE team. And because of that, I will define some metric types. First, platform metrics. For example, how many pods are running for a given service? How many containers are running for that service? or how many containers are pending for that service. In addition to that, virtual machine metrics like CPU, memory, and disk usage. Pretty simple. Docker metrics that basically are metrics split by containers. So we can see a given metric, how that container is behaving given the resources that the virtual machine is using. And we can't forget that inside that container, there's a service running. So of course, their service will also have its own metrics. The good news is that the SRE team provides the platform metrics, the VM metrics, and the Docker metrics. It means that the developers will only need to take care of the app metrics. Yeah, exactly. Moreover, they still have complete access to all the mentioned metrics, giving them the ability to do any analysis they need. Yes, even though we automate provisioning infrastructure, you will still have access and power to troubleshoot any issue you have, even if it's in the infrastructure. And of course, Datadog helps us with that. And it's worth mentioning that in addition to metrics, we provide them with many dashboards, default dashboards from the platform. It means C2C dashboards, where they can see how their containers and how their services are doing. And monitors to make sure that if something goes sideways, they will be notified and they will be paged. So to summarize, this platform is an SRE developed product, and as any other product at Klarna, we learn by iterating. This is a continuous process at Klarna. So we came from having every single team deploy their own infrastructure to having a container platform that automates all the chore of provisioning infrastructure and checking compliance. And the main learning and the takeaway from this talk is that engineers are a very scarce resource, and any company should utilize them wisely. Not to mention that having an SRE team focused on providing this product to all the product teams has been proven priceless for Klarna's growth. And that is the end. Thanks for joining, everyone. My name is Guilherme, and I'm the first C2C advocate you get to know. And I'm in Sweden, so that's why I'm going for my fika break, and I wish you a very pleasant cinema roll time.